products are there, whatever the contaminant or unusual products are going to appear here, they are going to be evacuated using the exhaust. So remember, an exhaust cover is here, which is going to collect each and everything if desired, otherwise it is going to be get evacuated. This is the system of a furnace. Actually, furnace is going to be put here. So furnace job is to make the substrate to be heated, by which whatever the materials are coming here, they are going to absorb properly, and they are going to be dried, and they are going to form the solid format. These things we discussed last time, that since you see here, in order to make these reactions, actually in order to make these reactions, if here the atmosphere requires, if here the atmosphere, this requires the atmosphere of a something, you say the controlled pressure. If controlled pressure requires here, controlled pressure, then for controlled pressure, what pressure you are putting where this material is going to be grown, on that basis this CVD process name is going to be changed. If this surrounding where this film is going to be grown, if that surrounding is of atmospheric pressure is to be maintained, then it is said to be the APCVD. So remember, if the where the reactive gases, actually if you say reactive gases are reactors are to be at the atmospheric pressure, then that is said to be the APCVD. If it is to be of low pressure, then it is said to be the LPCVD. If it is to be somewhere, you can say material is of in a nature that metal organic reactions are going to be takes place, those chemical vapor deposition is said to be the MOCVD. If you see that reactions, if whatever the this carrier gas and your target materials vapors are going to react, if are making it reactions, if suppose some you say here, if you sorry, where it has been, for that it requires the plasma, or you can say high radiation field required in order to make the chemical reaction, then that is said to be the plasma assisted or the plasma enhanced CVD. At the same time, if it is to be done with the help of laser, then it is said to be the LCVD. And if you see it is with the help of UV visible or some photochemicals help is going to impulse requires in order to make the chemical reactions of the your target materials and the reactive gases in the reactors. So that is said to be the PCVD. So on that basis, these nomenclature is specifically here UV is there in place of photo, UV is there, then this is said to be the UV chemical vapor deposition. So this way, this classification is going to be done of this chemical vapor deposition process. Its working already being explained in the last class. So again, you can see precursor gases are delivered into the reaction chamber at approximately ambient temperature. So this can be also, this can be, if it is going to be changed, then that nomenclature is going to be changed accordingly. As they pass over or come into contact with the heated substrate. So you have already seen that this is the substrate is to be heated. This is the furnace is here, heater is there, that furnace are heater. So furnace is there, that is in order to making it the heated surface of the substrate. So in this way, that surface is to be heated, and because of this heated surface, they react or decompose, forming a solid phase which are deposited onto the substrate. The substrate temperature is critical and can influence what reaction will take place. So you can see the temperature is also is playing a very crucial role in order to make the deposition proper, that how it is going to happen. Coating characteristics already being discussed. Why we are doing the coating? Because of the fine grain, because of the solid nature of the material, because of its purity nature, because of the hardness, each and every whatever we are saying here, these quality are available with the CVD process. This is another way of presenting this CVD process. So CVD process, this is the figure, you can say first one is figure 1, this is the figure 2. So you can see this is the different way out. Someone has made it differently. It has been made differently, where you can see that substrate is to be given here, that this is the substrate where it is going to get deposited the materials here itself. So this is the reactors. These are the furnace. You see here the furnace is in this way. Substrate is going to be put in this fashion. Your source and your carrier gas. So whatever target materials and whatever the carrier gas, both are, one is coming say far from here, one is coming from here. Say far this is the carrier gas, and say far this is the target material vapor. So both are coming here and they are flowing through the reactors. Here the reactors where actually substrate has been put. So once it is the vapor has been formed, then after forming the vapor, they are going to deposit over the substrate which is to be present here. So in this way, and whatever the excess residuals are present, they are going to evacuated using the exhaust. So you can say that this is the different way out how this CVD process is going to occur. This is already being said that gas delivery system is there, reactors are there, substrate loading mechanism is there, what energy sources you are using in order to creating the vapor, as well as in order to making it decompose over this substrate. So these things are actually required. At the same time, their vacuum systems are required, exhaust systems are required, process control equipment required. So these are the way out how you are going to manage the things. In order to prepare the thin films over the substrate. So this is the CVD process is to be happening. For the energy sources already being there, seen that these are the way out, they are going to be used, and accordingly the nomenclature of the CVD is going to be changed. What precursors you are using in here in the CVD process? So it's already being discussed last time. These types of precursors are going to be used, and materials which is to be grown over the CVD process, these are the materials are going to be. So you can say all types of materials are going to be grown. Specifically, what is to be used in the organic solar cell, in our semiconductor, transistors, whatever you are looking, all places these materials are going to be used. So they are going to use specifically. And often neglected byproduct of the CVD process are volatile gases. So whatever being the exhaust is going to be make it evacuated, they are the actually volatile gases. So you have to choose the reactive gases in that way by which they are going to make the extra, whatever the extra contaminant are present in the reactors, they are going to be evacuated automatically with the help of the carrier gas. So you have to choose accordingly. However, these gases may be toxic, flammable, or corrosive, so must be treated appropriately. So you cannot expose all the exhaust to the atmosphere. So for that reasons, you have already seen that those the exhaust scrubber are there. They are going to somewhere they are the unhygienic. So they are going to be controlled there with the scrubber. So analysis of the off gases can also be lead to a better understanding of the CVD reactions mechanism and the information used to refine the process. So you see, exhaust is very, very essential in case of the CVD. If exhaust process is not done clearly, then your thin films are going to be prepared with contamination. So that is not going to become the pure and highly, you can say, qualified film. So for that reasons, you have to very much sure that the evacuation of the contaminant gases has been done carefully. So applications, it is already being discussed that applications is to be across the wide range of industries, such as coating. What we said that coating for a variety of applications such as the wear resistance, corrosion resistance, high temperature protections, erosion protections and combinations thereof, water proof. So all these things can be done using the help of chemical vapor deposition techniques. Specifically the semiconductor industry already being discussed. In the semiconductor industry, it may be of the IC type, it may be the sensor, it may be the optoelectronic devices, it may be the spintronic devices. Dense structural part, you can see this is the structural way they are going to be modified using the CVD techniques. Optical fibers, people are also using in the optical fibers for the tape decommunication process. The materials are to be grown using the CVD techniques. Composite is going to be prepared using the CVD techniques, so such as carbon-carbon, carbon-silicon carbide, silicon carbide composites are going to be prepared using the chemical vapor deposition infiltration. So this is another techniques of the CVD classifications is to be done. Powder productions are novel powders and fibers. Catalysts are going to be prepared using this. Nano machines are going to, so these are the applications of CVD. So it's not, if someone is asking apart from the semiconductor industry, so you can name all these applications if required. I started this chemical vapor deposition techniques because of this pulse laser deposition technique. So how it is to be differed. So just you see, in first one, actually here the reactors are there, and the reactors are allowing that which types of films are going to be prepared over the substrate. Whereas in the case of pulse laser deposition techniques, which is the physical vapor deposition techniques, here actually high intense laser beam is going to be fall over the target materials, and those target materials, because of this high energy laser beam, they are going to create a plasma plume here, which is going to be because of the high energy, they are going to be scattered from here, and based here that substrate is going to be put, they are going to get deposited over the substrate. So these techniques are said to be the pulse laser deposition technique, since this laser pulses are going to be used in order to create the plasma plume, and it is going to deposited over the substrate. So these types of materials are going to be grown there in the transition metals. And if you see this is the very, you can say, very clear self auto explaining pictures are here. So you can see this laser pulse are here. This laser pulse are going to fall over the target material. So this is the target material. So this is the target material, and it is the laser pulse. So this is the laser pulse, high intense laser pulse, high intense laser pulse is going to be fall over the target materials, and from target materials, these are the due to because of the high energy, these are maybe in the form of atoms, in forms of ions, in forms of the molecules. They are going to sputtered from here, and the in front of it the substrates are here, which are going to attract these atoms and molecules, and they are going to deposit it over the material surface. So obviously the arrangement is there that a potential difference is going to created between these two, by which it is going to get attracted towards this side, but some scattering is also there that you have to control over here. But in this way, this process is going to occur. Obviously, whatever the surroundings you are looking here it's actually depends that which quality of films you are going to deposit here. It is based on what temperature you have maintained here, how much pressures you have given here, what gases are present here, in order to not making any you can say that unreactive gases are there, which are not going to make its reactions, but in order to make this instrument in a safe mode. So for that, these are the gauges are going to be applied for the pressure. Vacuum gauges are there and vacuum pumps are here. For the what types of gases you require, it is to be present here. How much temperature inside it is, that is to be the thermometer is going to be placed. So in this way, these PLD techniques are going to be created. But certainly you see, it is the distance you have put from the target materials to substrate, accordingly your deposition will take place. So if laser beams are going to come here, if it is to be the shorter distance, then it is going to deposit. The deposition is going to be take faster, as well as the more area per area deposition is going to be more in case where it is to be nearer, whereas when it is to be larger distance, then it is to be the lesser deposition will take place. But remember, since here high energy is going to be created, these pulses, so high energy laser beams are coming here. So whatever the atoms or molecules are coming here, they are having very high kinetic energy. So because of high kinetic energy, if they are very closer to this target materials, then the contaminations are going to occur in this substrate surface. So for that reasons, you may not get the very smoothened film. Whereas if it is to be longer distance, then those kinetic energy is going to be get dissipated in terms of the heat, and you are going to get the smoothened surface. So you have to take care each and everything in order to optimize, not very near, not very far. So you have to optimize the distance between the target material, target source, as well as the substrate. So the distance between target source and the substrate need to be controlled, need to be optimized in order to film the high quality films. So it is very important to know that what are the deposition parameters. If you are depositing the films, then what parameters actually you have to take care very specifically. These are the what target materials you are taking so far. For that you must have the very much experience, or you must have go through the literature survey, that how these target materials, if you are handling one target materials, related literature surveys must be completed first. Thereafter you will go through the pulse laser deposition techniques, what temperature you are using here, what gases or vacuum you have created, how much pressures are there inside the chamber where this deposition takes place, what are the distance between the target materials and the sample, target sample and the laser wavelength. That's also important. What we discuss here, this distance is important, as well as this distance is also very much important in order to make the growth of this film over the substrate. So pulse length, actually pulse length is also very important, that if pulse length is, suppose if the wavelength is very large, in that case your deposition nature is going to be changed. If it is short and having very high energy, at that time it is going to change. Also accordingly the nomenclature of PLD is also going to be changed, like laser ablations or pulse laser or the laser sputtering. So all those nomenclature is going to be differed. If distance is to be, if laser length means laser wavelength is going to be changed, then they are also going to affect the deposition of the thin films over the substrate. Pulse rate is also very important, and radiation intensity, what intensity actually you are providing of this laser pulse, they are also playing a crucial role in order to deposit the films, deposit the materials over the substrate. So what are the film properties you are looking so far in order to, when you are depositing the film? Then obviously the compositions need to be maintained. Crystallinity, we used to say when crystalline, when amorphous we require, accordingly based on this deposition parameter, it is going to be done. So whatever we are looking here, these are the deposition property, and if effects are going to happen over this film property, deposited films property. So it is going to affect the composition. It it is going to affect the roughness of the thin films, it is going to affect the conductivity in terms of the electrical of the materials, what is to be grown over the substrate. It helps in making the optical affect the mechanical property, biocompatibility, corrosion resistance, or you can say thermal property. Whatever property you are looking, they can be affected. They can be controlled using these deposition parameters. So remember these things also. So this is two techniques actually I was thinking to discuss today. If someone have any query related to these two techniques, they are welcome. They may ask. Yes.
Hello, sir. Sir, in last
So for
class
that
I
I
am
have
not
just
attending, but
repeated. I repeated.
today, sir, today I am attending, but I understand this laser pulse deposition. Sir, my question is, why we are using this deposition using like laser beam is coming to that target, that materials is going to substrate. If we heat that target material directly, we will coat to substrate. That will also possible to coating that materials, na? Why we are using like this technique? Is there any reason,
Exactly.
sir?
Actually, just you
Last,
see.
sir.
No issue,
Uh,
no issue.
uh,
Actually,
yeah.
actually, just you see, if you are going to deposit some things using the vapor only, if you are trying to make the something, so it's actually materials property. Say for if something is target material is there, and that target material may not be that much useful, or they want to make its vapor, they requires very high temperature. Say for if something, suppose something is based on the silicon materials or some materials is here, which requires a very high temperature, say for 2000 degrees centigrade, 2100 degrees centigrade. Means ultimately first they have to melt, thereafter they have to vapor, make the vapor. So for creating
Yes,
2000,
sir.
3000 degrees centigrade is not an easy job. Actually, it's a very dangerous. Even 1000 and 1500 is very
Yes,
dangerous. So
yes,
if
sir.
you
Yes,
are
sir.
using a controlled atmosphere and you are using a laser beam, say for here laser beam you are using, so laser control is in your hand, and they are able to create a specific points where actually you want to make the sputtering, that is to be very controlled. So for that persons, we are not preferring this much to creating this much temperature, rather than we are going for this laser pulses. If you are going to make it this of angstrom size or 10 power minus 11 you go, then it is a very high intense. It is going to create the atoms of any types of materials. Are you getting the point?
Sir, last point once again, sir. Last.
So it's higher the energy here. Higher the energy means if your this frequency, you can say wavelength is going to be shorter. If wavelength is going to be shorter, it means you are creating a very high energy. So
Yes, sir.
10
Yes,
power
sir.
minus 11, 10 power minus 10 meter. If you are going to create the laser pulse, they are going to grow. I mean, they are going to rupture of any kinds of films where we don't require this much temperature. Yes.
Sir, in case that laser will be not that much control, that will be affected to people's, I mean, surrounding ones also, na?
Actually, for that, you see, in order to controlling this much beam, that is rather very easy since you do have the techniques. But for creating the temperature, you see this always it is going to make that much temperature of that surrounding. So here you are not getting that much temperature. Temperature is of this way only, and here no any atmosphere is here. So it is going to easily, it is going to scatter everything here. But you see, not this technique is useful for all type of materials. Where these things are not going to work, then we are looking for this. Maybe here, in order to creating this much temperature, maybe contamination occurs. Since at that temperature they are going to melt, what surrounding is going to happen. So for that reasons, this laser pulses are going to be used here. Yeah, if you are going to ask something, then I may clear it much more. कुछ फिर से पूछिए, तो फिर I may create this tell you much more. मैंने क्या यहाँ पे बताया, पता लगा कि सब तरीके के मटेरियल्स को you are not going to use here. Here, specific materials are going to be treated using the pulse laser deposition techniques because of the quality of lasers at very, very small wavelength, shorter wavelength. Yes.
Sir, in CVD process, sorry,
Is
sir, I
it
am.
clear? Is it clear?
Yes, sir. Is it clear? But these lasers will gives that temperature reducing. But which material we want, that will be. I mean, which atoms we want, that atoms will be going to the target material, that
Correct,
substrate
correct,
material.
correct, correct, correct,
Okay, sir.
correct.
Sir, in CVD process, we are using that high temperature, na? Sir,
Not,
last time I am
not.
not here. That's why I am not getting this CVD process, sir.
नहीं,
But yes, sir.
हाँ हाँ बोलो
This
बोलो बोलो. हाँ
diagrams.
हाँ.
Here, this diagram, these carrier gases and these target materials is going to same path, and here we are consider something heating things like that. Here I am not understanding. So where our substrate is there, where it will be going.
Actually, just see, actually here I said you, these, you can make the substrate at any point since you have the furnace here. This is your furnace. This complete space is to be, complete space is for the substrate only. But for you right now, since these are the place where materials can be grown, but for you only I told here, rather falling these things, you just be very sure that whatever the gases, carrier gases has come and your target material has come, they are going to react here. These are the reaction, abstract reactions. This is the weapon, and those weapons are going to deposit here. I made that these materials are going to deposit here, but you may put here some membrane, and after putting membrane, your target, your substrate may have here also, it can be grown here also, but don't fall here. Rather, just you see it is going to be developed here, and whatever the contamination left, you must have provision in a way that they can be evacuated using the exhaust. Yes.
Sir, here target material is automatically going to recombine this carrier gases, or we will give anything to this target material is I mean, moving to these places.
It's a very schematic diagram. It's not actually the you can in situ figure. Rather than just you see when they both are going to be
Normally, sir, normally
they,
this target
yes, when they both are going to be meet, we are choosing this gas, carrier gas, we are choosing in such a way that once it is going to be make here, then out of TiCl4 Cl4 we want to deposit here, or titanium tetrachloride or titanium oxide we want to grow here. So titanium tetrachloride we are sending here, some oxide is coming here, titanium oxide is going to be separated it here, titanium oxide is going to be grown, less Cl and H is going to be evacuated in such a way that neither hydrogen, not the chlorine, not the carbon is going to be present here. Only titanium oxide is going to get deposited here. Yes.
Okay, sir. Sir, here this target material, these carrier gases, we will give any external force to these are going to this pathway. We will give any external force, na?
Yeah, everything is to be externally given. Here you do have the already knob is here in your things where you are going to provide those gas. Here you are having the different chamber where target materials is going to be put. They are going to be just sent from here. Both are going
Okay.
to be just mixed here. Once it is going to be mixing here, you must have here some provision that you can provide the laser light also. By if they are not going to react so easily, then you provide the light, or you may put here a furnace by which it requires little high temperature, then you are going to get here the heater by which they are going having some temperature, they are going to react together. So whatever you want, those things are going to be just made here. This is a very schematic diagram. Yes.
Okay. Wherever it's not I mean combined, we will give that place heat, and
That
it will
that
be
goes.
on.
Yes, yes,
Yes, sir.
yes.
it's combined only in subject, only TCO format, not another format.
No,
Yes, sir.
so whatever titanium sulfide, if you want to titanium sulfide you want to grow, then
Yeah.
accordingly sulfur gases is going to be flown from here. They are
Okay.
going to react here. So only the difference here, whatever the vapors are coming from the target materials, they are going to make a chemical reaction here. So for that, since chemical reaction is going to happen, vapor deposition is same. Vapor deposition is same. So if vapor deposition physically you are doing the high intense beam you are putting, and physically
Yes,
it is going to deposit, then it is PVD. If vapor deposition is going to be deposit after a chemical reaction, that chemical reaction is going to be done of any mean. Either you are providing this furnace, you are providing the laser, you are providing UV visible, you are providing whatever, low pressure, high pressure, it doesn't matter. But if chemical, after chemical reaction it is going to be deposited, then it is said to be the CVD. Yes.
Okay, okay, sir. Okay, sir. Okay, I got it, sir.
Okay. Anyone else? Any query?
Sir, in case of CVD purpose,
Someone is saying, but I am not listening actually. Someone is saying something, I am not listening. If someone is listening, then they may explain me. Yeah. है कोई बताएगा क्या कौन पूछ रहा है?
No, sir, not understanding, sir. Once again, ask.
If someone is there, then please ask. I am here to explain. No.
हाँ सर, हेलो
हाँ बोलो.
हेलो सर.
हाँ बोलो.
Sir, for CVD purpose, our material should be in a solid powder form or liquid form, sir.
हाँ, कुछ भी होगा. मान लो यहाँ पे अगर लिक्विड रखे हो या सॉलिड रखे हो, ये मैटर नहीं करता. अगर यहाँ सॉलिड रखे हुए हो तो इसको सबसे पहले यहीं पे फर्नेस तुम्हें प्रोवाइड करना होगा. इस फर्नेस से या यहाँ पे हीट देना होगा, जिससे पहले वेपर में कन्वर्ट हो जाए. गैसियस फॉर्मेट, सिंस reactions are going to occur in the vapor format only the gaseous format. Yes. तो यहाँ पे कुछ भी दे सकते हो, लेकिन अल्टीमेटली उसका गैसियस फॉर्मेट में उसको बदलना है, वेपर फॉर्मेट बदलना है, तभी रिएक्शंस होगी. अगर उससे पहले कोई रिएक्शंस होती है वो नहीं माना जाएगा. वेपर फॉर्म में जब रिएक्शंस होगी, देन एंड देन इट विल सेट टू बी द केमिकल वेपर डिपोजिशन. यस.
Sir, these techniques we will observe in practical way. Is there any lab to observe these things?
Obviously, actually established laboratory. Not right now. We are here. We are actually in a very growing phase. But if you will go to the IIT Kharagpur and IIT Kanpur, it is a very common. Actually, material science center, always you are going to get this chemical weapon and PLD techniques, very common. But for us, actually, since we are not working the semiconductor people, we are not material science people, we are physics people. So we are just working on a very, you can say, in university since growing phase, we are doing namely either this micro based or somewhere this solution are chemical based or the auto clay. Yeah, these techniques we are using namely. But in the IIT Kharagpur, if you will go, or IIT Kanpur you will go, certainly you will find it very common technique. Someone else? Not? हाँ, कोई पूछ रहे थे, उनका क्या हुआ, खत्म हुआ? कौन पूछे थे? उनका क्वेरी सॉल्व हो गई?
Yes, sir. Yes, sir. Vinod Patel.
Okay, good. So let us come for the attendance. आप ही तक जितना पढ़ाया गया, जो हमने पढ़ाया है, जो अगर फिर कोई क्लास होती है तो उसको भी लेना होगा, लेकिन अभी तक जो पढ़ाए हैं, जो सुरेंद्र जी ने पढ़ाया, जो कमलेश ने पढ़ाया, सबके क्वेश्चंस आपके आएंगे. आपके एग्जाम में सब जगह से उतने आएंगे. हमने जो अभी तक पढ़ाया है ये आएगा. तो जस्ट यू बी रिमेंबर, बी prepared with this way. And this exam is descriptive or objective?
Sir, some subjects is objective, some subject in subjective, sir.
So ours, this nanostructure materials.
Sir, subjective.
Okay. So it will come. So be prepared accordingly. ना? जो कि इसमें आपको सिमेट्रिक डायग्राम सब बनाना होगा. जो हमने यहाँ दिखाया है सब आपको बनाना होगा पेंसिल से. तो बी वेरी केयरफुल ना. डिस्क्रिप्टिव में आपको ज़्यादा मेहनत करनी होगी. तो उसी तरीके से अभी तक डिस्क्रिप्टिव आपने दिया नहीं है, तो आप उस तरीके से रेडी रहिएगा. ठीक है?
Sir, can you mention which type of questions will become? We are first time this exam.
No, obviously, if you are, I'm asking the CVD techniques, then you remember I may ask that just make the symmetric diagram of CVD and discuss about this how this CVD process, CVD technique work, and what are their applications. So this way, these questions are going to come. What are the conditions? What are the property? What are the parameters is to be controlled using this this CVD techniques or the PLD techniques or whatever techniques? Actually, your important thing is you must have the idea about their thematic diagram. You must have the idea that they are each and everything, so how they work, what their job. That you must need. Ultimately, how films are going to be grown. Obviously, where are the source target materials, where are the substrate has been put, everything you must be very clear in the pictures. Thereafter, their flow chart diagram, how they are going to deposit, what are the process, and which types of material is going to be grown, and what are their application. I think this is the sufficient in these cases, but we are studying right now.
Okay, sir.
Is it okay? Are you all want the questions?
Sir, up to today class, na we have exam, sir.
If next when our exam is there, I think first
one sir.
अभी होगी class, अभी class होगी.
During MST also class.
Oh, अच्छा MST है ना, so it's okay. So अभी तक जो हुआ है वही आएगा.
Sir, can you send up to here PPT, sir?
I'll say.
Okay, sir. Thank you.
Sir, which book we can refer?
कौन पूछ रहे हैं अभी, क्या बोल रहे हैं?
Sir, any book we can refer for this?
Oh, actually, I can refer you the books, but you cannot get each and everything in a single book. Actually, there are a number of books, so 2-3 books I'll share. Na?
Okay, sir.
Okay.
This PPT is enough to our exam.
Obviously, but elaborations, required elaborations, you may go through the internet, you may go through the everything. Since I am also teaching you based on the what I understand from the what we are actually doing here, based on what internet is available, what is to be available in the book. So it needs to be the multi-way it has been put there. So
PPT
is sufficient. PPT.
Yes, sir. Okay, sir. Thank you.
Okay, so
the PPT.
Your attendance is open. No, attendance, just you give the attendance. Hello.
Yes, sir.
Anjana. Asgar.
Yes, sir.
Atul. Brahmanan.
Yes, sir.
Abdul. Diya.
Present, sir.
इप्सिता क्लास के लिए पूछ रही थी, अभी है नहीं. कल्पना.
Present, sir.
किरण.
Present, sir.
कुलदीप.
Present, sir.
मगन.
Present, sir.
मुरली.
Present, sir.
नमिता.
Present, sir.
नवीन.
Present, sir.
रोहित. रोशन.
Present, sir. Rohit.
रोशन.
Present, sir.
सागर. सारंग.
Present, sir.
सिंपल.
Present, sir.
सौरभ.
Present, sir.
हर्षिता.
Present, sir. Sir, Suprabha.
सुप्रभा.
Present. Yes, sir.
Okay. Ritam. Harshita.
Present, sir.
Ritam. Samarkand. Satish.
Yes, sir. Present.
Shweta.
Present, sir.
Soumya.
Present, sir.
Veera. Rahul.
Present.
Yogesh.
Present, sir.
Itika.
Present, sir.
विनोद को नहीं बोला. Okay. वीरेंद्र.
Present, sir.
Okay. Anyone
सर
else?
इप्सिता प्रेजेंट, वो माइक काम नहीं कर रहा था.
Okay, मैंने बोला कि इप्सिता तो बोल रही थी. Okay. Anyone else?
Sir, Adul Krishna present.
Atul.
Adul Krishna.
Okay.
Adul Krishna. Yeah.
Anyone else? No. Oh, okay. Good luck to you all.